First question is, find the least number which after being increased by 2 is exactly divisible by 8, 16 and 24. See, first thing we have to see is here in this question it is asked to find the least number which is exactly divisible by the numbers, the given numbers. So if we have to find out any number which is divisible by some given number, this means we have to find out the LCM. Now, one more thing is given here in this question, that least number will be divisible by 8, 16 and 24 after being increased by 2. Now, if we find the LCM of 8, 16 and 24, so that LCM will be exactly divisible by 8, 16 and 24. But we have to find out the number which after being increased by 2 is exactly divisible. So after finding the LCM of these numbers, we will subtract 2 from that LCM so that we could get the least number which is required. So let us first find out the LCM. So number exactly divisible by 8, 16 and 24 is equals to the LCM of 8, 16 and 24. Now let's find the LCM of 8, 16 and 24. So we can divide these numbers by 2. 2 4s are 8, 2 8s are 16 and 2 12s are 24. Again divide the numbers by 2. 2 2s are 4, 2 4s are 8 and 2 6 are 12. Again divide the numbers by 2. 2 1s are 2, 2 2s are 4 and 2 3s are 6. Now in the remainder you can see there is no common factor between any of the two numbers. So we will leave the division here and LCM will be 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3. So it will be 2 into 2 4, 4 into 2 8, 8 into 2 16 and 16 into 3 48. 48 is the LCM of 8, 16 and 24. But this is not the final answer because 48 is exactly divisible by 8, 16 and 24. We have to find out the least number which after being increased by 2 is exactly divisible, which means the number which is required is 2 less than 48. Therefore, required least number is equals to 48 minus 2, that is 46. Next question is, find the greatest number that can divide 166 and 237, leaving remainders 5 and 7 respectively. So here we have to find out that greatest divisor which can divide 166 and 237 and the remainders will be 5 and 7. Now to find the greatest divisor we can find out the HCF of these two numbers, but because of the remainders we cannot get the HCF because they are not exactly divisible by the highest common factor. So what we have to do is firstly subtract these remainders from the numbers. So 166 minus 5, it will be equals to 161. 237 minus 7, it will be equals to 230. Because when we subtract the remainders from the numbers, then the dividend becomes exactly divisible by the divisor. Now the numbers are 161 and 230. So now we can find HCF of 161 and 230. So find their HCF, write 230 as the dividend, 161 as the divisor. 161 ones are 161. Subtract them. 0 minus 1, 9. 12 left. 12 minus 6, 6. Now the 69 is the new divisor, and now write 161 as dividend. Divide 161 by 69. 69 twos are 138. Subtract them. 11 minus 8, 3. 5 left here. 5 minus 3, 2. Now 23 will be the divisor, and write 69 as dividend. So 23 threes are 69. Remainder is 0. Therefore, the last divisor, that is 23, it will be the HCF, which means greatest number required is equals to 23. Next question is, find the greatest 4-digit number which is exactly divisible by 55, 88 and 110. So firstly, we have to find out the LCM of 55, 88 and 110. So let us find the LCM of 55, 88 and 110. So all the three numbers are divisible by 11. 11 fives are 55, 11 eights are 88 and 11 tens are 110. Now 8 and 10 both are divisible by 2. So take 2 now and divide the numbers by 2. Write 5 as it is. 2 fours are 8 and 2 fives are 10. Now 5 is common here, so write 5 and divide the numbers by 5. 5 ones are 5, 4 will be written as it is, and 5 ones are 5. Now there is no common factor in any of the numbers, so LCM will be 11 into 2 into 5 into 4, that is 11 into 2, 22, 22 into 5, 110, 110 into 4, 440. Now this 440 is the LCM of these three numbers, which means that if any number is divisible by 440, that number will also be divisible by 55, 88 and 110. Now we know that greatest 4-digit number is 9999. We have to find out that greatest 4-digit number which is exactly divisible by 55, 88 and 110, or we can say which is exactly divisible by 440. So divide 9999 by 440. 442s are 880. Subtract them. 9 minus 0, 9. 9 minus 8, 1. And 9 minus 8, 1. Bring down the next 9. Again 442s are 880. So here 9 left. 9 minus 8, 1. And 11 minus 8, 3. 319 is the remainder, which means 9999 is not exactly divisible by 440. If we subtract this remainder from the dividend, then the difference between these two will be exactly divisible by 440. Therefore, the required greatest number will be equals to 9999 minus 319, which is equals to 9680. So this 9680 is the greatest 4-digit number which is exactly divisible by 55, 88 and 110. The next question is find the minimum length of a rope which can be cut into whole number of pieces of length 36 cm, 48 cm and 60 cm. So to find that minimum length of rope we have to find the LCM of 36, 48 and 60. Therefore minimum length of rope required is equals to LCM of 36, 48 and 60. So let's find the LCM of 36, 48 and 60. Divide the numbers by 2. 2 18s are 36, 2 24s are 48, 2 30s are 60. Again divide them by 2. 2 9s are 18, 2 12s are 24, 2 15s are 30. Divide these numbers by 3 now. 3 3s are 9, 3 4s are 12, 3 5s are 15. As you can see the remainders are 3, 4 and 5. Here no common factor is there in all the numbers. So LCM is equals to 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 4 multiplied by 5. So 2 2s are 4, 4 3s are 12, 12 3s are 36, 36 4s are 144 and 144 into 5 720. Therefore answer is required length of rope is equals to 720 centimeter. Next question is find the smallest number which on being added 5 to it is exactly divisible by 9, 21, 25 and 45. Now we know the number which is exactly divisible by the given number will be equals to the LCM of these numbers. But in this question we have to find that smallest number which on being added by 5 means we have to add 5 in that number to make it exactly divisible by 9, 21, 25 and 45. So firstly we will find the LCM of these numbers. After that we will subtract 5 from that LCM to get the smallest number which is required in the question. So let us first find the LCM of 9, 21, 25 and 45. So write all the numbers 9, 21, 25 and 45. As you can see that all the numbers are not divisible by a single number, but 9, 21 and 45 can be divided by 3. So let us first divide these numbers by 3. 3 3s are 9, 3 7s are 21. 25 is not divisible by 3, so write 25 as it is. 3 15s are 45. Now again 3 and 15 are divisible by 3, so take 3 as divisor. 3 1s are 3, 7 will be written as it is, 25 will be written as it is and 3 5s are 15. Now take 5 as divisor, 1 will be written as it is, write 7 as it is, 5 5s are 25 and 5 1s are 5. Now in the remainders we have 1, 7 and 5. which have no common factor. So LCM will be equals to 3 into 3 into 5 into 7 into 5. So their product is equals to 1575. Now this 1575 is exactly divisible by 9, 21, 25 and 45. But the number which we require is 5 less than 1575. Therefore, required smallest number will be equals to 1575 minus 5, that is 1570.